let's talk about multiplying polynomials. Okay, in order to multiply polynomials, we use a lot of distributive property. What about x minus 4 times 2x plus 7? Okay, in order to multiply these, I need to multiply everything from the first parentheses, everything, times the entire second parentheses. So I would need to take the x, and I would need to multiply it by the second parentheses, 2x plus 7. I would need to take the negative 4, and I would need to multiply it times the second parentheses. If I had another number, I'd have to take it out and multiply it by, you've got it, the second parentheses. Let's get to work. X times 2x is 2x squared. X times 7 is 7x. Be careful here. Negative 4. Negative 4 times 2x is negative 8x. Negative 4 times 7 is negative 28. I have a few alike terms here. I have a positive 7x and a negative 8x. It will be 2x squared minus 1x, or just x, minus 28. Okay, there is another way I can multiply polynomials sometimes. Sometimes I can use FOIL, but you can only use FOIL when you are multiplying, not adding. Do not do it when you're adding. Only when you are multiplying two binomials. FOIL, it stands for the first, and the outer, and the inner, and the last. So if I would like to multiply this same problem again, I look at the first term, x times 2x. That will be 2x squared. Then I look at the outer terms, positive x times a positive 7. That will be a positive 7x. Then the terms that are on the inside, the innermost terms, that's a negative 4 times 2x. Remember, we are multiplying the first. We are multiplying the outer. We are now multiplying the inner terms. Then the last term in each parentheses, the negative 4 times 7, that would be negative 28. And then you can add your like terms. So I will have 2x squared minus 1x, or just x, minus 28. The same answer that I got when I did it by distributive property. But remember, you can only use FOIL when you are multiplying two binomials. Let's try this problem. I am multiplying. I look between my parentheses. There's not a plus or a minus there, so I am multiplying. This is a binomial times a binomial. I can use FOIL. First, outer, inner, and last. The first term, 3x times x, that would be 3x squared. We're going to multiply the outer terms. 3x times 4 is 12x. We will now multiply the inner terms. 2 times x is 2x. And now we are multiplying, not adding. So many students get here and they want to add. No, you multiply the first, you multiply the outer, you multiply the inner, and what do you do to the last? Yes, you are right. You multiply the last. And then it does look like I have some like terms. I have a 12x and a positive 2x. That would be a positive 14x plus 8. Let's try one more problem. Okay, so once again, we are multiplying polynomials. This time I have x plus 4, and there's not a plus or a minus between there. I am multiplying. I'm multiplying it times x squared plus 3x minus 10. This is not a binomial times a binomial. I don't have a choice to use FOIL. I have to use the distributive property. So everything in the first parentheses has to be multiplied by everything in the second parentheses. I will take out the x from the first parentheses. I will multiply it by the second parentheses. I will take out the positive 4. make sure you write the sign or a -4, whatever it is. This case is a positive. I will multiply it by the second parentheses. And now we're ready to do a lot of work. X times x squared is x to the third. X times 3x, 3x squared. Keep going. I get minus 10x. Now positive 4 times the second parentheses. And now I add my like terms. So for like terms, I believe that is my only x to the third. I'm just going to sort of cross it out. I'm not going to scribble it out. Just cross it out just so I'll know that I have used it. Positive 3x squared and a positive 4x squared. That will be a positive 7x squared. Once again, I'm just going to slightly cross them out so no, they're gone. Here is a negative 10x and a positive 12x. That will be a positive 2x. And it looks like I only have one constant,